4a, to find the first partial derivatives of fx and fy. For fx, I got 4x minus 4y, and then for fy, I got negative 4x plus y squared minus 5. And the work I did, since we know the formula partial derivative, x to the n, y to the m equals nx to the n minus 1, and then multiplied by y to the m. So I took the original formula that I was given for this problem, and I used that formula for both of these, and that is how I got those. For b, to find the critical points, so from these formulas, we got fx equals 0, which is 4x minus 4y, and then since that equals 0, and then we know that x equals y, so fy equals 0, and then here is all of my work right here. But ultimately, as you work through it, we get that y equals 5 and negative 1. So when y equals 5, then x equals 5, and then when y equals negative 1, then x equals negative 1. And the critical points are negative 1, and then 5, 5. For C, to find the second partial derivatives, fxx equals 4, fxy equals negative 4, fyx equals negative 4, and then fyy equals 2y. And then my work, here's my work for fxx. Again, using that partial derivative, and then 4x minus 4y equals 4. For fxy, the partial derivative, and then the 4x minus 4y, there's the work, and then fyy, and the partial derivative, and then using that negative 4x plus y squared minus 5, and then that got me 2y, and then fyx, and then using that same formula from the previous one got me negative 4. And then for D, I got D55 equals, which would equal 4 times 10 minus 16, which equals 24. And then D, negative 1 equals 4 times negative 2 minus 16, which equals negative 24. So now that D55 is greater than 0 and fxx is greater than 0, so that means the relative minimum is at 5, 5, and D negative 1 is less than 0, so the saddle point is at negative 1, 1, and then this is given that the function has no relative maximum.